All right, today we'll be working on related rate problems. These are the application problems from derivative. So whenever the related rate problems are given, these are the derivative with respect to time. That's why we called the rate problems. So rate of change with respect to time, the derivative with respect to time. That's what we are calculating. So here you'll see word problems and you need to solve the word problems. While solving the word problems, you need to uh, you need to follow a specific procedure to solve those problems. And here I have listed 5 important steps that you'll be following while solving any related rate problem. The first one, of course, is read the problem, not just read for fun or anything like that. Read to understand the problem. And if required, try to represent it diagrammatically. Then identify the rates and other information given in the problem. And also try to determine or try to find what is asked in the problem to find. Okay, try to locate in the problem what is asked. And then second step is to write the equation or relation connecting various variables in the problem. Then next step is to find the derivative on both sides with respect to time, because we are working on the related rate problems. So we are calculating the derivative with respect to time. So because you are differentiating with respect to time, you are differentiating x with respect to time, y with respect to time, or some other variable with respect to time, you are following the implicit differentiation. Then once you perform the differentiation, you plug in the information and solve for what is asked in the question. And after you get the answer, always remember, try to give your final answer using a proper sentence and also using the proper unit. Example, determine the rate of change of profit with respect to time when x equal to 50, that is the number of items, 50, and dx over dt, that is change in x with respect to time, is equal to 40 items per hour. And they have given that the revenue function r of x, that is the revenue function, is 80x minus 0.25x squared, and the cost function is 5x plus 80. So what we are going to do is, we are talking about the revenue, we are talking about the cost, and we are talking about the profit. I don't think we need to draw any kind of picture here. Instead, let's first write what is given. So here, what we have to find is, we have to find the rate of change of profit. Okay, we have to find rate of change of profit, that is change in profit with respect to time is how much. Okay, determine the rate of change of profit with respect to time when x is equal to 50, that is given to you, when x equal to 50 items, and dx over dt, change in number of items with respect to time, is equal to 40 items per hour. They have given the revenue function, they have given the cost function, but we want to find the change in profit with respect to time. So what we need is the profit. So we know the relation for the profit. We know profit is equal to the revenue function minus the cost function. If this is new to you, make sure you remember this. Profit is the revenue function minus the cost function. Whatever revenue you make, from there, if you subtract the cost, the remaining is your profit. This implies your profit function will be equal to revenue. You can see your revenue is 80x minus 0.25x squared. 80x minus 0.25x squared, then minus the cost function. We are subtracting this one, minus 5x plus 8. So this is equal to, okay, we have the x squared here, which is negative 0.25x squared. Let me write that first, negative 0.25x squared. Then here we have 80x, and we are subtracting 5x. 80x minus 5x is 75x. And then we are also subtracting 8. minus 8. So this is my profit function. So we calculate the profit function by subtracting the cost function from the revenue function. Okay, once we have the profit, you can see we are asked to find the change in profit with respect to time. That is, we have to differentiate this on both sides with respect to time. We are differentiating x with respect to time, so it's going to be the implicit differentiation. So let me write that. Differentiating both sides with respect to time. We are differentiating both sides with respect to time. On the left hand side, we have a profit differentiated with respect to time. So it is dp over dt, change in profit with respect to time. If you want to write that x there, that's okay. And here, when you differentiate this with respect to time, 0.25 is a constant. And here you'll use the power rule. So in power rule, that 2 will come in front and multiply with that. So 2 times negative 0.25 is negative 0.5. Negative 0.5. We reduce the power of x by 1. So it will be x raised to 1. We are differentiating x with respect to time. So this is the implicit differentiation. So we have to multiply by dx over dt, change in x with respect to time. Then plus 75 is a constant. You are differentiating x with respect to time. That is dx over dt. And then the derivative of constant will be 0. Okay, let's simplify further. I'm looking for that dp, change in profit with respect to time, that is equal to, you can see in these two functions, in these two terms, dx over dt is a common factor. So I'm going to factor that out. And if I factor that out, I am here with negative 0.5x, negative 0.5x plus 75 multiplied to dx over dt. Now I have the expression or a formula to find the change in profit with respect to time. So once we have ready, or once we have everything ready, or once we have this formula ready to find dp over dt, we are going to plug in the information and calculate that value. So dp over dt, change in profit with respect to time, is equal to negative 0.5. See, we have to find the change in profit with respect to time when x equal to 50. So value of x is 50 times 50 plus 75 multiplied to dx over dt, that's also given, that's equal to 40. So which implies dp over dt is equal to, now if you look at the screen carefully, you'll see 50 times negative 0.5 is negative 25. Negative 25 plus 75 is positive 50. 50 times 40 is 2000. 2000. So the change in profit with respect to time is 2000. Let me write that sentence here. The change in profit, or you can also say rate of change of profit, change in profit with respect to time is 2000. But when you see here, it is the profit with respect to time. So profit is counted in terms of dollar. Okay, with respect to time, so dollar per, the unit of time given here is hour. So the profit is changing at $200 per hour. It's positive, meaning of that is profit is increasing at $200 or at the rate of $200 every single hour. Example, if the radius of a beach ball is increasing at a rate of 1.5 centimeter per second, how fast is the volume changing when r equal to 5 centimeter? So here, let's see what they have given. See, if the radius of the beach ball is increasing at the rate of 1.5 centimeter per second. So we are given that the radius is increasing 1.5 centimeter every second. So meaning of that is they have given dr over dt, change in radius with respect to time, is equal to 1.5 centimeter every second. So every second, the radius of the ball is increasing. Now what we have to find is, we have to find how fast is the volume changing. dV over dt, change in volume with respect to time, is how much when radius is 5 centimeter. When radius is equal to 5 centimeter. When the radius was 5 centimeter for this ball, how fast is the volume changing, given that the radius is already changing at the rate of 1.5 centimeter per second. So here we are talking about the volume and the radius of the ball. So we have the formula connecting that. So we know the volume of the ball is equal to 4 over 3 pi r cubed. That is the formula to find the volume. Now, we are talking about the rate, so we are going to differentiate on both sides with respect to time. So let me write that. Differentiating both sides with respect to time. What do we get? If we differentiate the left-hand side, change in volume with respect to time, dV over dt is equal to 4 over 3 pi, that is the constant multiple, multiplied to, we have to find the derivative of r cubed with respect to time. When you find the derivative of r cubed, you use the power rule. So you'll bring that 3 down, reduce the power by 1, but you are differentiating radius with respect to time. So this is the implicit differentiation. You multiply by dr over dt. Then in next step, change in volume with respect to time is equal to, here you can see 3 and 3 gets cancelled. So you get 4 pi r squared, 4 pi r squared multiplied to dr over dt. So this is the formula. This one is the formula to find the change in volume with respect to time. Now we are going to plug in the value. So change in volume with respect to time is equal to 4 pi multiplied to radius squared. We are calculating this change when the radius is 5. So 5 squared multiplied to change in radius with respect to time is 1.5 multiplied to 1.5. So if we simplify this, dV over dt is equal to, so if you look at the screen, 5 squared is 25. 25 times 4 is 100. 100 multiplied to 1.5 is 150 pi. So I get 150 pi. And then if I plug in the value of pi and simplify this one, 150 times pi in our calculator, it should be 471.24. So that is the change in volume with respect to time. Or you can also say the rate of change of volume. So let's write the sentence. So volume is changing. In this case, it is positive, meaning of that is it is increasing. So the volume is increasing at a rate of 471.24. Now you can see it is change in volume with respect to time. Unit of volume is centimeter cube and the unit of time here is second. So the volume is changing at the rate of 471.24 centimeter cubed per second. Example, a 12-foot ladder. So this one shown in the picture, this is 12. 12-foot ladder is leaning against a house, and that is the wall of the house. So this would be wall of house leaning against the house. The base of the ladder begins to slip away from the house. So if this distance, I don't know what is this distance from the base of the house up to here. If this is x, then what is going on here is the ladder is slipping away from the house. That means the value of x is increasing. So this is what they have given. The base of the ladder begins to slip away from the house at the rate of 0.5 feet per second. Every second it's going away 0.5 feet. So change in x with respect to time is equal to 0.5 feet per second. Unit of x, or the distance, is feet and time is second. So as this is going away, you know that if the vertical distance is a y, from here to here, if it is y, then the tip of the ladder is moving down. That means the y value is decreasing, it's going down. Okay, so what you have to do is, how fast is the top of the ladder moving down? Top of the ladder moving down, that is dy over dt, change in y with respect to time, is equal to how much? How fast is the top of the ladder moving down the side of the house when the ladder is 3 feet away from the house, when this x is 3 feet? When x is equal to 3 feet. That's what you have to find. We have to find dy over dt equal to how much? When x equal to 3 feet. So we are calculating this rate of change when x equal to 3 feet. So let's find out when x equal to 3, what will be the value of y? Let's first find that before we calculate the rate. When x equal to 3, I'm doing this math over here. We don't know what is y when x equal to 3. But what we know is this side is squared, which is y squared, plus this side is squared. Now it is x equal to 3. 3 squared is 9. Is equal to this side of the triangle is squared, which is 12 squared, 144. This is the Pythagorean theorem. Square on the hypotenuse is equal to sum of squared on the other two sides. So y squared plus this side we have 3, because we are calculating the change when x equal to 3, is equal to the hypotenuse squared. So if you subtract 9 on both sides, you'll get 144 minus 9, which is 135. So y will be equal to square root of 135. So meaning of that is, when x equal to 3, y is equal to 135. Now we are going to take this general equation for this triangle, which will be, let me write here, x squared plus y squared equal to 12 squared, 144. So as x increases and y decreases, this relation is always true, because this ladder will always form a right triangle. So x squared plus y squared equal to 144. Now I'm going to differentiate this on both sides with respect to time. So differentiating both sides with respect to time, what we get is, you find the derivative of x squared, you bring that 2 down and reduce the power by 1. It will be 2x using the power rule. And you are differentiating x with respect to time, implicit differentiation. So multiply by dx over dt. Then plus, if you differentiate this y squared with respect to time, just like x squared, you use the power rule. So it will be 2y times dy over dt, change in y with respect to time, equal to, here the derivative of the constant, that will be 0. So because I'm looking for dy over dt, I'm going to keep this quantity on the left hand side and move this to the right hand side. So I get 2y times dy over dt, that is the second term, is equal to, if I move this term on the right hand side, it will be negative, or if I subtract that term on both sides, it will be negative on the right hand side. So minus 2x dx over dt. Now you know that I'm looking for dy over dt, so I'm going to keep that on the left hand side. Dy over dt. So in order to just keep that dy over dt on the left hand side, I have to divide on both sides by 2y. So here I'm dividing by 2y, and here also I'm dividing by 2y. So that 2y get cancelled on the left hand side. On the right hand side, 2 and 2 cancel. You can see 2 and 2 cancel. There is a negative, and then you have x over y, this x divided by y, and also I have dx over dt, dx over dt. So this is the formula to find change in y with respect to time for the condition given here. Now we are going to plug in the values to find the value of dy over dt. So we get dy over dt is equal to negative, and then we have the x is 3, because we are calculating the change when x equal to 3, divided by, when x equal to 3, we already know what is y. When x equal to 3, y is square root of 135. Square root of 135 multiplied to dx over dt. This is already given to you. Dx over dt is half, or 0.5. So that is 0.5. Now we can simplify this using calculator. Dy over dt is equal to negative, then 3 over square root of 135. Multiply that answer by 0.5 in your calculator. You should get negative 0.1291. Negative because this y value is decreasing. This x is increasing. That's why that change was positive. It was increasing at the rate of 0.5 feet every second. Whereas this y value is decreasing. It's coming down at this rate. So we can say our question was, how fast is the top of the ladder moving down? So we say the top of the ladder is moving down, that is negative, at the rate of negative 0.1291. Y value, this distance is measured in feet. Okay, because we have dy, that is the unit of that, per time, unit of time is second. So the top of the ladder is moving down at the rate of negative 0.1291 feet per second. Example, the altitude of triangle is increasing at a rate of 2.5 centimeter per minute, while the area of the triangle is increasing at a rate of 3 centimeters square per minute. At what rate is the base of triangle changing when altitude is 12 centimeter and area is 84 centimeters squared? So what I'm going to do is, first I'm going to draw a triangle here and then try to explain you what is going on. So let's draw a triangle there. Suppose we have a triangle ABC. Suppose the altitude of the triangle here, altitude or height of the triangle is H, and the base of the triangle is B. Now let's find out what is there. The altitude of the triangle is increasing at a rate of 2.5 centimeter per minute. That's given to you. Here, the altitude or height of the triangle is increasing. So dH over dt, increasing means it's positive value, 2.5 centimeter per minute. 2.5 centimeter per minute. Height is increasing. The height of the triangle is increasing at the rate of 2.5 centimeter per minute. Well, the area of the triangle is also increasing, and the area, total area, dA over dt, change in area with respect to time, that's the rate of change of area, is 3 centimeters squared per minute. 3 centimeters squared per minute, because the unit of area is centimeters squared. It's a square unit. So that is given to you. Now what we are asked to find is, let's find out what is there. At what rate is the base of the triangle changing? Height is increasing, that's given to you. Area is also increasing. Now we have to find at what rate is the base changing. We don't know whether it is increasing or decreasing. We'll find that. So at what rate is the base changing? dB over dt, change in base with respect to time, is how much? When the altitude is 12 centimeter, we are calculating this when the height is 12 centimeter and area is 84 centimeters squared. We have to find the change when the height is 12 and area is 84. Now what I'm going to do is, when the height is 12 and area is 24, let me write that here. When height is 12 and area is 84, at this situation, let's find out what is the base. So for that, what we know is area of triangle is half base times height. Area is 84, that is given to you. Half multiplied to, I don't know what is base, but they have given the height. Height is 12. So 84 is equal to half of 12 is 6. So that is 6b. So b is equal to, so if you want to find the value of b, divide on both sides by 84. So it will be 84 over 6. And 84 divided by 6 is 14. That means when the area is 84 and height is 12, the base is 14. And we are exactly asked to find the change in base with respect to time. When the height is 12, area is 84, and you can say when base is 14 centimeter. Now let's do some calculus. We know the formula connecting the height, base, and area. So that formula is, let me write here. We know area is half base times height. Area is half base times height. Now, if I want to differentiate this with respect to time on both sides, it will be dA over dt, derivative of area with respect to time, is equal to, this half is a constant multiple. So when you're finding the derivative, that half will remain in front, half. And then here, you're calculating the derivative of the product, base times height. So you have to use the product rule. Product rule says first function base times the derivative of second, derivative of height with respect to time. That is dH over dt. Plus the second function. Second function is the height multiplied to the derivative of first, derivative of base with respect to height. Derivative of base, I mean with respect to time. So we use the product rule to find the derivative. Okay, in order to find this dB over dt, when all these values are known, when the height is known, area is known, and also the base is known, all we have to do is we have to plug in the information here. So dA over dt, change in area with respect to time, it's given here. Change in area with respect to time is 3. 3 is equal to half multiplied to the value of base we calculated here, 14. 14 times dH over dt, it's given here. dH over dt is 2.5. 2.5. Then plus the height is 12 multiply to dB over dt. That's what we are calculating. We don't know what is that. Let me write dV over dt as it is. So in next step, since this 2 is dividing here, so if I move it to the left hand side, it will multiply. So that will be 6. Or if I multiply here by 2, 2 get cancelled. And if I multiply on the left hand side by 2, that will be 6. Equal to, now you have to multiply this one. 14 times 2.5. 14 times 2.5 is 35. You can try that in your calculator. Plus 12 dB over dt. Then subtract 35 on both sides. 6 minus 35 is negative 29, equal to 12 times dB over dt, which implies dB over dt, change in base with respect to time, is equal to, so if I just want to find this dV over dt, I have to divide on both sides by 12. If I divide here by 12, it will be dV over dt. If I divide this by 12, it is negative 29 over 12, little more than 2. You can do that in calculator. It should be 2.42. 2.42. And the unit of base, how long is the base? It will be measured in centimeter. And time here is measured in minute. And we got the result negative. Meaning of that is the base is decreasing at the rate of 2.42 centimeter per minute. So the meaning of this one is base is decreasing because the rate is negative. That's why it is decreasing at the rate of 2.42 centimeter per minute.